Hello and welcome to this 14th set of problem on AP, GP and HP. So as always I'll say that when I'm reading the problem you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further delay, let's get started. Problem 131 says that the second, third and sixth terms of an AP are consecutive terms of a geometric progression. Find the common ratio of the GP. So we let A to be the first term and D to be the common difference of AP. Now it is given that the second term, the third term and the sixth term of the AP are in GP. So we can write that third term, which is A plus 2D whole square, is equal to second term, which is A plus D, into the sixth term, A plus 5D. So we get this as A square plus 4AD plus 4D square, and we multiply these two to obtain A square plus 6AD plus 5D square. A square will get cancelled, 4D square will get subtracted, it will become D square, and 4AD will make 6AD as 2AD. So we will have 2D square plus 2AD is equal to 0. Now D is not equal to 0, so we take out D and we will have D plus 2A is equal to 0, which gives us D is equal to minus 2A. Once we have this value of D, common ratio of the GP can be obtained as the third term by the second term, that is A plus 2D by A plus D. Or if you want, you can choose sixth term by the third term, that is A plus 5D by A plus 2D. It won't make a difference. So this we substitute D is equal to minus 2A, the numerator becomes minus 3 and denominator becomes minus A, and we have common ratio of the GP as 3. Problem 132 says that a sequence of numbers is formed by adding together corresponding terms of an AP and a GP with common ratio 2. The first term of the sequence is 57, the second term is 94, and the third term is 171. Find the fourth term. Find also an expression for the nth term of the sequence. So we let A to be the first term and D to be the common ratio of the AP. We also let A prime to be the first term of the GP. Now the common ratio of the GP is 2. So when we add first terms, we get A plus A prime is equal to 57. The second term would be A plus D plus AR, but AR in the sense that A of first term of the GP, which is A prime, and R is 2. So A plus D, that is the second term of GP, and the second term of AP and second term of GP is 94. Now the third term of AP would be A plus 2D, and the third term of GP would be A prime R square, that is 4. So A plus 2D plus 4A prime is equal to 171. Now from here we can write that 2A prime plus D is equal to 94 minus A. Okay, so then we take this and we substitute over here. So this is 4A prime plus 2D. So this is twice of 2A prime plus D. So we can write that A plus 2 into 94 minus A. We take this value and substitute here, and twice of that is equal to 171. This gives us A is equal to 17. Once we have A is equal to 17, we can get A prime from this relationship, that is A is equal to 40. Once we have A is equal to 40, we can substitute in this one. We get D is equal to 3. We have 94 minus 40, that is 54, and 94 minus 17, that is 77, and then 2A prime 80. So 77 minus 80 is minus 3. So our fourth term would be A plus 3D plus 8A prime. This is the fourth term of AP, and A prime 2 to the power 3 is fourth term of GP, which will be 328. So nth term of this sequence would be 17, that is the first term of AP, plus n minus 1 into minus 3 plus 40, that is A prime, into 2 to the power n minus 1, which is in effect equal to 20 minus 3n plus 10 into 2 to the power n plus 1. Problem 133 says that the first, 8th and 22nd terms of an arithmetic progression are 3 consecutive terms of a geometric progression. Find the common ratio of the geometric progression. If sum of the first 22 terms of the arithmetic progression is 275, find its first term. So we let A to be the first term and D to be the common ratio of the AP. Then we are given that first term into and 8th term and 22nd term. First 8th and 22nd term of the arithmetic progression are in geometric progression. So first term into 22nd term is equal to 8th term whole square. This gives us d is equal to a by 7, because a square will get cancelled here. This will be 21 ad will be left, and this side 49d square plus 14 ad will be left. So when we bring 21 ad from here, it will give us minus 7 ad. So we take 7d common from this, and d is not equal to 0. We will be left with 7d minus a is equal to 0, that is d is equal to a by 7. Once we have this d, we can write r is equal to 8th term of the AP by the first term of AP, because these two are consecutive terms of the geometric progression. We substitute d is equal to a by 7. This becomes, numerator becomes 2a and denominator is a, so common ratio is 2. Once we have common ratio is equal to 2, we can write that sum of 22 terms is equal to 22 by 2 into 2a plus 21 into d is equal to 275. So 22 by 2 is 11 and 275 by 11 is 25, and here we substitute d is equal to a by 7, so 7 3 are 21, so 3a plus 2a 5a, 5a is equal to 25, a is equal to 5. So we have found the first term. Problem 134 says that an arithmetic progression has common difference 2 and a geometric progression has common ratio 2. A new sequence is found by adding together the corresponding terms of these progressions. Given that the first term of this new sequence is 8 and the fifth term is 91, find the first terms. So we let a and a prime to be the first term of the AP and GP respectively. Then we are given that a plus a prime is equal to 8. Now remember, common difference is 2 and common ratio is also 2. So the fifth term would be a plus 5 minus 1 into 2, that is a plus 8, plus a prime r to the power 4, that is 2 to the power 4, that is 16. So we have 91 here. We take the value of a plus a prime as 8 and we substitute simply over here. So we get 8 plus 8 16, and 15 a prime will remain here. So 15 a prime is equal to 91 minus 16, that is 75. So a prime is 5. Once we have a prime is equal to 5, we substitute here and we get a is equal to 8 minus 5, that is 3. Problem 135 says that if ABC are in AP and BCD are in HP, prove that AD is equal to BC. So ABC are in AP, so 2B is equal to A plus C, and BCD are in HP, so C is equal to 2BD by B plus D. We cross multiply this, we get BC plus BD is CD, BC plus CD is equal to, now here we substitute 2B is equal to A plus C, D into A plus C, and then we cancel out CD, we get BC is equal to AD. Problem number 36 says that if ABC are in HP, BCD are in GP, and CDE are in AP, show that A is equal to AB square by 2A minus B whole square. So we are given that ABC are in HP, so B is equal to 2AC by A plus C. Then we are given that BCD are in GP, so C square is equal to BD. And finally we have CDE in AP, so 2D is equal to C plus E. Now, okay, how do we go about this? So from this relationship, we have AB plus AC is AB plus BC is equal to 2AC. So we take BC this side, we get C is equal to AB by 2A minus B. Now E is equal to 2D minus C. So we substitute the value of D from here, we get 2C square by B minus C. Now we substitute the value of C from here, we get this as 2 into A square B square by B into 2A minus B whole square minus AB by 2A minus B, and then we take LCM and solve it, we get AB square by 2A minus B whole square. Problem 137 says that if an AP and a GP have the same first and second terms, then show that every other term of the AP will be less than the corresponding term of GP, all the terms being positive. So in this case, if we prove that nth term of arithmetic progression would be what it says, every other term of the AP will be less than the corresponding term of GP. So if we can prove that nth term of the GP or n plus 1th term of the GP is greater than n plus 1th term of the AP, then our desired theorem is proven. So what we do is we take AR to the power n minus A minus ND, that is nth term of the GP minus nth term of the AP. Now we are given that they have the same first and second term. Okay, so the second term of the AP would be A plus D. So R can be written as A plus D by A. That is what is here, which is A plus D by A, which will become 1 plus D by A. So we write this whole to the power n minus A minus ND. Now we expand this binomial theorem, we get this. Now if you don't know binomial theorem, then you can skip the problem and you can come back to this when you have studied binomial theorem. Once we have expanded this NC1 will be n, and D by A will remain D by A. So when it will get multiplied with this, it will become ND, and when A will be multiplied with 1, it will become A. So A will get cancelled with this A, and ND will get cancelled with this. So what will remain is A into rest of the expression. Now since D by A is greater than 0, so the entire sum would be greater than 0. This proves that nth term of the GP would be greater than nth term of the AP. So all the corresponding terms of the GP would be greater than the corresponding terms of AP. Now the important thing to note here would be that all terms are positive. So because all terms are positive, D by A has to be positive. Otherwise all terms won't be positive. Problem 138 says that if three unequal numbers are in HP and their squares are in AP, show that they are in the ratio of 1 plus square root of 3 to minus 2 is to 1. Sorry, 1 plus square root of 3 is to minus 2 is to 1 minus square root of 3, or reverse of that. So we have let ABC as three numbers in HP, then we are given that B is equal to 2AC by A plus C. This is from HP relationship, the formula for midterm, and the squares are in AP, so 2B square is equal to A square plus C square. Now we let A is equal to CK, so over here we put CK. We have not substituted the value here, so we have this. So here we substitute the value of B, so it becomes 4A square C square by A plus C whole square, and then it multiplied with 2, it becomes 8A square C square by A plus C whole square. This is equal to A square plus C square. Now this we cross multiply, and then we substitute A is equal to CK. Once you substitute A is equal to CK, you can take out A square from this common, and that will get cancelled with this. And then hang on, so power 2 here, power 2 here, yeah. Then this A becomes CK, so C to the power 4 K square. Now from here, if we substitute CK here, it becomes C square K square. So we take C square common, so one C square will be gone, other C square will remain. From here, CK plus C whole square, it will become C square if taken outside, and then inside K plus 1 whole square. So C square from this will cancel out this second leftover term of C square. So this becomes 1 plus K square into 1 plus K whole square minus 8K square is equal to 0. Now this is an equation of K with maximum power 4. That means it will have 4 roots. Now if you observe carefully that this is satisfied, one of the cases is that K is equal to 1, in the sense that if three numbers are equal, then their squares will be in AP. So for example, 111 in HP, then 111 in AP. So that is true. If 222 are in HP, then 1 by 2, 1 by 2, 444 will be in AP. So one of the cases would be when all the terms are equal. That is possible if K is equal to 1. And now since we have squared this, there will be two roots of value 1. So if you understand that, you can easily factorize this equation, and you can write this as k minus 1 whole square multiplied with k square plus 4k plus 1 is equal to 0. And since the numbers are unequal, k cannot be 1. So k is minus 2 plus minus 3. Now that will give us a to c. Now that ratio is nothing but 1 plus square root of 3 is to 1 minus square root of 3. If you rationalize this, then you will obtain the same result. Or it is 1 minus square root of 3 is to 1 plus square root of 3. It is that a is to c. Once we have this, that is, we know the ratio of a is to c, we can simply substitute over here and we can find the value for b in terms of k. Problem number 139 says that if a, g, h are the arithmetic, geometric and harmonic means of two positive real numbers a and b, and if a is equal to kh, prove that a square is equal to kg square. Find the ratio of a to b. For what value of k does the ratio exist? So we have a is equal to a plus b by 2, h is equal to 2ab by a plus b, g is equal to square root of ab. Now we are given that a is equal to kh. Okay. So a plus b by 2 is equal to 2kab by a plus 2, a plus b. So this a plus b will get multiplied and this 2 will go here. So it becomes a plus b whole square is equal to 4kab. So this, if you substitute ab from g, it will become g square. Okay. And then this 4 you can take here, so a plus b by 2 whole square. So that means a is equal to kg square. Now we let b to be m into a. Then we substitute over here. Okay. Hang on. This should be a square, not a, because a plus b by 2 whole square is equal to a square, as stated here. It is a typo. It is a square. Now we let b is equal to ma. So we substitute in this. We get a square outside. Inside we have 1 plus m square is equal to 4k ma square. This a square will get cancelled. So we have 1 plus m square is equal to 4k m. So m will be 4k plus minus square root of 16k square minus 4 by 2. That is 2k plus minus square root of 4k square minus 1. Now we are given that a plus b whole square, not given, we have obtained that a plus b whole square is equal to 4kab. So we subtract 4ab here, we subtract 4ab on both sides, that is. So we obtain a minus b whole square is equal to 4kab minus 4ab. That is a minus b whole square is greater than 0. So this will have to be greater than 0. This will be greater than 0 only if k is greater than or equal to 1. Problem 140 says that if p be the rth term when n arithmetic means are inserted between a and b, and q be the rth term when n harmonic means are inserted between a and b, then show that p by a plus b by q is independent of n and r. So we let if we insert n harmonic means between two terms, total number of terms would be n plus 2. We let d to be the common difference of ap and d prime the common difference of corresponding hp. So we get d is equal to b minus a by n plus 1, and d prime would be a minus b by n plus 1 into ab, because d prime would be 1 by b minus 1 by a divided by n plus 1. So that will result in this value. Now p is a plus rd, so we obtain that as n plus 1 into a plus r into b minus 1 by n plus 1. And similarly we obtain the rth term of hp, that is q is equal to n plus 1 into ab by r into a minus b plus n plus 1 into b. Now we substitute this in the expression p by a plus b by q, which gives us this much. Now if you observe carefully, here we have r into b minus a, here we have r into a minus b. So these two will cancel out, and the denominator is same in both the cases. So since the denominator is same in both the cases, we will have n plus 1 into a on the top and n plus 1b into the top. So that will be n plus 1 into a plus b. So n plus 1 will be common, so n plus 1 will get cancelled with the n plus 1 in the denominator. So it will be a plus b by a, which is independent of n and r. With this, we come to the end of 14th set of problems, and in the next video, I will show you the next 10 problems. I hope you have found this video useful and informative. If such is the case, please subscribe to the channel and like the video so that it can reach more people and they can benefit from us. If you have a comment or suggestion or a question, please use the comment box. And I hope you have really enjoyed this video. Thanks a lot for watching. Enjoy.